Okay, it is the 14th of September. 9, 14, 17. Terrible handwriting. This is the start of Chapter 2, and this is where we do start to talk a lot more about scientific measurement. So this is where we start our math, but we're not going to do that today. Today we're going to talk about science. And we're going to talk about what science is and isn't. Is science the only way of understanding the world? No. There are a whole bunch of lenses through which we can view the world and understand the world. Science happens to be one of those lenses. Other lenses include religion, philosophy, art. Those are all lenses through which to understand the world. Science is a tool that we can use to understand natural phenomena. Okay? And when I say natural phenomena, I mean sort of within the scope of science as we know it. And we're going to talk about how we differentiate scientific ways of understanding the world from non-scientific ways of understanding the world. Is either of them better? No, but they are applicable in different instances. So there's a film we watch in biology called Hunting the Nightmare Bacteria. I subjected some of you to it if you had me for biology. And there's a microbiologist at the National Institutes of Health who talks about doing a culture which comes back with a bacteria that is resistant to every drug we know of. Every antibiotic that we know of. And she says to someone else in the lab, a senior researcher, what do you do when you come up against a bacteria that is resistant to every chemical that we know to throw at it? And he said, I pray. And she said, okay, that is the point at which we have reached the end of scientific medicine, because that is not within the scope of science. That is outside the scope of science. So religion is a way to understand the world that's outside the scope of science. Philosophy is a way to understand the world that's outside the scope of science. Like I said, art and literature. Scientific ways of understanding the world have to be consistent, observable, natural, predictable, and testable. And it's important to remember that they're tentative. They're tentative. So, I want to talk about what each of these means. Did I misspell consistent? I probably did. When we say that an explanation is a scientific way of understanding the world, for one thing, it has to be consistent with the way that other things that we are aware of and understand work. And so, in terms of consistency, that means that things like the way atoms behave here on Earth is the same way that atoms behave on Jupiter, or on Pluto, or in the sun, or in some other solar system that we're unaware of. That everywhere in the universe as we know it, the rules are the same. And so when you come up with an explanation, or someone comes up with an explanation, you have to say, is there some sort of exception being made to a scientific law? Because if so, it's not a scientific explanation. And one of my secret goals for you guys, because I have my on-paper goals, which is that you're all ready to walk into a college chemistry classroom, and college chemistry is pretty easy for you, and you get through the next step. That's my on-paper goal. My secret goal for you is that you develop good BS detectors. Seriously. Because I think science is an incredibly powerful tool for understanding the world and not getting hoodwinked, for not getting sold a bill of goods. And there's lots of stuff out there that's pseudoscience that sounds kind of scientific because they throw some scientific terminology in it. But if you start to look at it, it may not be consistent with everything else that we know. That's the first thing. It's got to be observable. We have to be able to either take in information about the event or the phenomena directly, or we have to be able to look at evidence of the event or the phenomena with our senses and create sort of a trail from that. Who here thinks that they are an awesome observer? No one? Seriously, none of you are observant? I think I should put that to the test this year. I should just start doing stranger and stranger things, which wouldn't be all that out of character for me. So, Gesundheit. Observations are limited to the facts. They are limited to the facts of the situation, and they are limited to sensory information. So I got a little game for you here, a little activity, if you're up for the challenge. Now, none of you think you're good observers, so I don't know how this is going to work. If you have a blank piece of paper or a blank slide or whatever else, I want you to be ready to write some stuff down because I want to see how your observational skills are. I'm going to perform a series of actions up here. I'm going to move everything out of the way. Move my giant coffee cup, move my ruler, move my weird salt block, all that stuff. Can't get rid of all the papers. And what I want you to do is write down everything that you observe that I'm doing. I'll now pause the recording. Okay. Science has to rely on the natural. Gesundheit. Science has to rely on the natural. What that means is we can't invoke supernatural explanations. So the natural are things that are observable with our senses. If it is observable with our senses, with ordinary sensory types of equipment, the type that you and I are equipped with, eyes, ears, nose, mouth, or with scientific sensory equipment, the aid of scientific instruments, microscopes, balances, electron microscopes, nuclear magnetic resonance imaging. Ooh. Shake up the little organic chemicals and see what little spikes you get on a graph, and you can tell what kind of chemicals they are. That's all natural observation. Supernatural explanations are anything that is outside the normal and observable. It's a miracle. That's a supernatural explanation. It is outside the natural. Okay? Again, think about the microbiologist at National Institutes of Health. What do we do when we hit bacteria that are resistant to all known antibiotics? We pray. Okay, that's a supernatural solution. When you've run out of natural, okay. So supernatural is not just ghosts. Religion deals with the supernatural. It's ideas of things that are beyond the natural. If you had me for biology, you heard this, but I'll go through it again, because I will. That tea kettle is whistling, and I can give you an explanation. Well, one explanation would be that the water inside is being heated, therefore the particles are moving faster, they're moving further apart, and they are then forced to travel out through a narrow opening in this little cap, which makes a membrane vibrate, and the vibration of that membrane causes a high-pitched sound. Does that sound true and logical and correct? We'll take out the whistle. Okay. Could the reason that the tea kettle's whistling also be that Moser walked over there 10 minutes ago, turned it on, and forgot about it? Right. Can they both be correct simultaneously? Yes, they can. The point being that there can be different lenses through which we see the world, and because there are two explanations for a phenomena doesn't necessarily make one more or less correct, but they explain it differently. So science explains the natural observable. In science, we don't know who turned the tea kettle on. No idea. And it doesn't matter. It does not matter. Okay. Science is predictable. It allows us to make predictions. If I am going to assume that all matter is made up of tiny little particles, take your 4 minutes, we'll be back. So we said science is predictable. If I believe, if my hypothesis, my working explanation, I hate the term educated guess. It's terrible. Terrible. It's not. It's a working explanation. If my working explanation for matter is that it's made up of little tiny pieces that vibrate, that move around, and that the hotter they are, the faster they vibrate, and that when they vibrate, that may create sound waves in air, if that's my hypothesis, then I can test that, because I can say, well, if I put this kettle on this burner and I apply heat to the kettle, then those water molecules should move faster. And when they move faster, they should spread apart, they should be forced out through this opening, they'll make that vibrate, and this darn thing's going to whistle. And I can test that hypothesis by turning the burner on. So it allows us to predict, and we have to then test those predictions. So it is predictable and testable. Here's the other part that doesn't get talked about too much, and I want to make sure you're clear on it. It is tentative. Whatever today's science is the best we know now. It changes. Things will change in your lifetime. Things have changed in my lifetime. Science changes. We never prove anything in science. I know you've heard that before. We just continue to try to disprove it. Best quote about the nature of science was by Brian Greene. He's this rock star physicist. Like, seriously, he's a rock star physicist. He did a big 3-part PBS series called The Elegant Universe explaining string theory, which is one of the leading hypotheses for everything. Everything. Why all this is here, how it works. And Brian Greene, this was an interview I heard with him about the nature of science, said, well, I've been working on string theory for, at the time, it was like, 22 years, and every morning I get up and I go to work and I try to break the theory. Huh? Every morning he gets up and he tries to disprove the thing that he has been working on for 20-some years. And he said, we might do it someday, and then, well, I guess I got to do something else. That's what we do in science. We continue to try to, let's see. Well, at the outside edge, if that was true, then this would not happen. Well, if that was true, then this would happen. Oh, no, it happened. Okay, we must have been right. We keep continuing to pick away at it, and science does change. Not only depth of understanding, but phenomena that we observed and we made an inference about in one direction, we can have continued data that comes in that leads us to change the inference that we made. Scientists continue to investigate, they continue to pull in more data, they continue to make observation, and they continue to discuss their research and their findings. So when scientists miss the boat, when scientists are dishonest about their data, then we go back and we revise. When scientists just, find something new that no one has observed before, we replicate, we go back, we add more. So, one last slide, and then I'm going to cut you loose. I'm going to hand you a lab, and I'm going to let you start your pre-lab. Scientific methods, and you notice that I put an S there where you probably learned in like 4th grade or so, the scientific method, step 1. Who here has done step 1 of the scientific method? Step 2 of the scientific method. I think that's totally bogus. Okay, it's not. It's a good place to start when you're 10. But science, you're not 10. None of you are 10. You're older than that. Science is really a mindset and a set of tools. More than a cookbook, cookie cutter. Step 1, step 2, step 3. And the sort of foundation of a scientific mindset and of a scientific way of moving through the world is observation, being observant. And this improves your life. I'm a big believer in the idea that science can improve your life. Science has lots to offer you outside of science. And being observant is a really powerful idea in life, in science. Being observant. Asking questions, questioning what you're seeing. Well, that's odd. Why is that? Well, how does that work? Well, why are those over there and not over there? Being observant, asking questions about the observations, and collecting data. And you're collecting data all the time informally. As teachers now, we talk a lot more about data-driven instruction. So I do things like pre-assessments with you guys where I want to see where you're at before we start on something. And part of that is collecting data so that I better know how to help you succeed. Collecting data and forming hypotheses about it. Forming working explanations based on the observations and the data that we've collected. When we say data versus just making observations, observation sounds a little bit more casual. Oh, the hills are misty this morning. Data would be actually going out and measuring air density. Taking percent water composition readings on an instrument. I mean, we can also have, we'll talk a little bit about the difference between quantifiable and qualitative data, qualitative and quantitative data. But data is a little bit more regimented. It's documented. Once you have a hypothesis and you have data, you got to test it. This is the testable piece. So controlled experiments, of course, are sort of the gold standard in science. One thing gets one treatment, one thing gets no treatment, and you see if there's a difference. And from that testing, you have to draw conclusions. You got to draw conclusions once you've tested. So, okay, we're actually going to stop there. I'm going to go grab the labs that you're going to summarize. You will have some time to summarize the labs, and today is Thursday. We may do a brief math assessment. I'll see. If we don't do it today, we'll do it tomorrow when you walk in. So, and it's a no points. I just want to see where everybody's at in terms of math.